Problem 13.9 on page 440. I've preloaded the Silver Springs rentals data set. We will once again skip the scatter plot because we did that in an earlier chapter. And we're going to calculate the least squares regression for the B0 and B1. The size of the apartment will affect the amount of rent. The rent won't affect the size. So the size is the independent variable and the rent is the dependent variable. So the size is your x-axis and rent is your y-axis. So if you were to draw this in a normal XY diagram, your square footage would go along the bottom and your rent would go along the vertical axis, the y-axis. So in this particular case, we go to data analysis under the data tab, by the way, go to regression. We want to input the y, which in this case is the rent column. So we're going to select the rent data. And then we are going to select and I'm just going to type it in this particular case, change my mind. I'm going to select A1, A58. I'm going to make sure to have the labels off or on. I have a tendency to forget to do that, so I'll try and remember not to. What that does is it tells the computer that the first either row or column heading is not data, it's the heading. So in this case, you'll see that when we have the printout. I'm going to select an area that's anywhere to the right, as long as it's in any of the white space, as long as it's not overwriting the area from A1 to B58. So any of the blank space, I'll put it up here. Doesn't matter where, as long as it's not wrecking or covering up some of the raw data, then it won't work. And we go, okay. So in this particular case, we can see that, I'm going to make the columns a little bit bigger here, that in this particular case, when we interpret it, when we interpret the results, what do we have? Make this a bit bigger. So B0, is 181.87 repeating. Is if you had square footage of 0, the rent would still be 781. How you get a square footage of 0, I'm not exactly sure, but there would be perhaps shared or whatever, but that's the calculation. B1 would be that for every square foot, you basically have to pay 98 cents. So if you have 10 square feet, that would be $9.78. So the predicted values will be based on the formula. So your Y will look like this: 781.87 plus 0.789. 3x. So that's what your equation will look like in part B. So in this particular case, as I have already mentioned, the y-intercept would be 0, and it's stated you can't have a square footage of 0, so it's not meaningful in our particular case. But you still have a meaningful value in that the monthly rental is expected to increase by 0.978 or 97.8 cents per square foot. Now, in this particular case, in Part D, they want to know how much would it cost to rent an 800 square foot apartment. So you go to 781.87 plus 0.9783 times 800. And helps if I type the formula. That'd be a really rather expensive apartment. And your expected value is $1,564.51. Now, in Part E, in this particular case, in Part E, the model of data, so the square footage, if I'll show you, the square footage, the minimum, and the maximum. So just going to type it in. So the minimum square footage is 434. The maximum square footage from A1 to A58 is 955. So this model is based on square footages for apartments that are 434 to 955 square feet. So if you have a apartment that's 1,500 square feet, as it says in the problem, then that's it's outside of our range. It's not within the parameters. And perhaps apartments that are that large would have a very different cost structure or rental price structure once you get to a certain square footage. So we would not say that that is a valuable model because the data set is based on different size apartments, not 1,500 square feet. Now, if we had a different data set that was based on, say, 1,000 to 2,000 square feet, then that would be appropriate. So in Part F, you are looking at an apartment with some friends, and you can see that you have an 800 square foot apartment for $1,130, which is less than the predicted value. 800 square feet should cost you $1,564, as we calculated earlier. And we also have one for 830 square feet. So in this particular case, in Part F, so in F, we already know the answer for the 800 square foot is this number here, right? And the 830 square foot apartment would be intercept plus 830 times slope. Oops, don't need the bracket. Now, if you're looking at, in this particular case, you've been offered this apartment $1,130 when it should be costing you $1,564, and this apartment has been offered to you at $1,410, so it's still a good deal. The difference between the two is better deal, at least from a rent point of view, is the 800 square foot apartment. because it is $434.51 undervalued according to our model. You should be paying $1,564, but you're only paying $1,130. And the bigger apartment would be more money, which you would expect, but it's not worth it. They're going to charge you an extra $30 a month for the apartment, and that's only $183 less for the 1,410 square foot apartment. So both apartments are good deals. The 800 square foot apartment is a better deal than the 830 because it's $434 below market value, what should be compared to the 830 square foot, which is about $184 below value. So you get a better deal with the 800 square foot apartment, and you can use, realtors do use this kind of thing for especially homes. What should a home be? And we're going to, in chapter 14, we're going to deal with things that are more than just square footage. This is based purely on square footage. There's other factors like location, how old the building is, things along this line. But we'll deal with that in chapter 14 because that is called multiple regression. In this case, in chapter 13, we are only dealing with single regression. One factor, in this case, square footage.